Yes. Today's our question is maximum square area by removing fences from the field. So there is a large m cross m minus 1 into m minus 1 rectangle field with the corners 1 comma 1 and m comma n contain same horizontal and vertical fences given in the array h fence and b fences. Okay, horizontal fences are there, vertical fences are there, and we have to return the maximum area of the square field that can be found by removing some fences and or minus 1 if it is impossible, and we have to return the modulus area of 10 to power e to power 9 plus 7. Okay, here if we want to have a square, we should see a proper gap is there between horizontal frame and vertical frames. So if they are equals, then we can have squares because squares have same sides. So the gap between these horizontals should be same and these verticals should be same. Okay, here there is no similar gap between horizontals or verticals. Therefore, here the answer will become minus 1. Okay, so the points are some fences can be removed, but the boundary fences cannot be removed. Our goal is to have the biggest, our goal has to have biggest square, and it will be the minimum of the side can will be the minimum of this horizontal gap, vertical gap. This is the vertical gap and this is the horizontal gaps. Okay, there are multiple gaps can be there. So whatever the horizontal gaps minimum will be there and which will be in vertical gaps also, our answer will be that. Okay, so suppose we have a H fence and B fence. So we have added the boundary. So how our answer will be looking like? See, if the difference between these two, suppose the difference between H naught and H2 is also exists between H1 and this one, then there is a common side which can, suppose this is A, this is A, then horizontal gap is also A, vertical gap is also A, then it will form square. Else, if it is not equal, then it will be different. It will not be square like that. And and we can say like that. We have we can compute all the gaps, and if the gaps exist in the both direction, then there is a valid square side. If not, then it is not. See, we will firstly take logically we will go. We will take all the horizontal gaps and vertical gaps all. Okay. Sorry. Okay. If so, time complexity of taking this will be O of that s dot size square, and it becomes O of 600 square, and it will become O of 1 into 10 to the power 4 versus 12 into 10 to the power 4, and it is inside our time complexity. So we can run this loop also. Okay. Whatever the common gaps will be there, that will be our answers. Common gaps in horizontal and common gaps in vertical. These both will having some common gaps now. Common gap. So this will be our answer. And the maximum of this common gap maximum of these common gaps will be the side of the square. And we have to return area max equals to max side into max side. and modulus of 1e9 plus 7. Okay, this will be our answer. Now let us see the code. So we have firstly added the boundaries to the edge, horizontals and verticals. Now we will see what are the gaps here. In this, gaps in horizontal. This one is horizontals gap. This one is verticals gap. Okay, whichever will be the same in horizontal and vertical. We will see what is the maximum between horizontal and vertical gap. And if there is no gap, we will return ct equals to -1 only. If there is any one of the common gap, then we will return the maximum one and return ct into c. The percentage of lng is modulus of 1e9 plus 7. Thanks.